Okay, today I'm going to walk through what I have been doing in the last week for my evolutionary robotics and my stack robots. Um, this week, I was originally planning on um, implementing a similar evolutionary algorithm and fitness function for my hive mind, but I kind of completed that when I was making the hive mind. I managed to kind of like do both at the same time. So what I did this week was I kind of made a new evolutionary algorithm for both of the um, uh, types of neural networks that I'm using, the distributive mind and the hive mind, um, with a goal that they will do something that will interact with each other so that the maybe give a chance for the hive mind to really shine. That is the goal. So right now what I have is for a fitness function is I have, and actually you can kind of see a little bit of my output over here. I have it printed out so we can see. I am not running it currently. I just have the output of a recent run so that I can explain what is happening. So I have part of it is a distance. And so instead of before I had them all meeting up and measuring the distance from their midpoint, I am just measuring their fitness as having walked to the origin, and I'm putting them in a circle around the origin, and I'll show that in a quick run later. So I have a hyperparameter here, which is the weight of the distance fitness, as I'm calling it. Here I also have a weighted thing where I am penalizing them if they flip over onto their back. I am doing this because I am giving them a score with their own hyperparameter here. If they manage to get their top sensor activated. So the flip penalty is if the orientation of the robot ever turns upside down in the X or Y direction. And the sensor fitness here, this value right there, is going to be rewarded by looking at the last 10% of the simulation length, and how many frames a certain robot's top sensor is active. And then all of these, since there's lots of robots, I'm kind of summing them up and multiplying and doing some things like that to reward the group. The flip penalty is steep, so that if they do flip over and they're activating their top sensor that way, they're actually losing fitness because of that. The evolutionary algorithm, so not the fitness function here, is now, let's see if I can show some example right here. So it works similarly to the parallel hill climber, but the it takes the top 3 scores from all the parents and children and brings those on to the next generation. So it's a little bit different than the hill climber, and I just wanted to see if it worked well. What it will do is it will reward parents, and if a child is still good and better than the other it might occur that like one parent spawns lots of children and those children are also very good, and so I wanted to see if I could reward one thing kind of winning out and kind of working lots of different angles from that. Okay, so we can kind of see that we have these various fitness displayed right here. So that was that, and let me go ahead and run the simulation so we can see it, and so we can see the other part that I worked on. The robots now, you'll notice here, are all spawning in a circle around the origin. So I wanted to give them all a good shot. You notice this guy just flipped over. So this was probably, I didn't run this one very long. So that's probably not going to be a very good run, especially because this guy seems to be walking away from the origin, etc. This is what you get for only running 2 generations. This guy's making it to the origin here pretty nice. I like his little trot. I like his little leg down there. That's kind of funny. Looks like a good stable. So this one probably actually, since it probably did the best out of them. And look at that. So this guy's actually touching the top sensor a couple times there, and it might be near the end there. So that is exactly what I'm looking for. So as I ran this example, I am also gathering a lot of data on it. So I have it saving a lot of the sensor values and the motor values of each individual robot in here as the .npy extension. And I'm also keeping track of all of their XYZ coordinates and rotations in this positions.npy. I'm hoping that what I'll do with that is eventually I'll be able to graph their trajectories of the best runs. And what I'm hoping to also do is implement that part during evolution. So every 10 generations or so, I can take the best one and map out on a graph the best result of that generation. So we can see generational progress in both the hive mind and the other one, and give me something to visualize and look at to see if one is doing better than the other. Okay, I've chatted long enough. Thank you. Bye.